Let's derive L'Hopital's rule for an indeterminate limit of the form 0 on 0. So if we start off with a definition of these derivatives, and now if we divide these two together, noting that x minus c cancels. And here we've assumed that the functions f and g are both differentiable, and the derivative of g at c is not 0. Now for the special case, where both f of c and g of c are both 0, then we can get rid of these terms. And now as x approaches c, we have a ratio of 0 on 0. And we can also write this ratio of the derivatives at c in the following limit form. So that's basically the same thing. And by L'Hopital's rule, taking the limit of the functions is the same as taking the limit of the derivatives, where we have the indeterminate form 0 on 0. So let's quickly have a look at this example. So we have the limit of two functions. So as x approaches c, which is pi on 2 in this case, we can see that we have an indeterminate form of 0 on 0. So if we take the limit of the ratio of the derivatives, we can see that this evaluates to 1. So we can observe that the derivatives, or the slopes of the tangent to the curve of both functions, become the same as x approaches pi on 2. And this is true from both sides. Let's derive L'Hopital's rule for the indeterminate limit of the form infinity on infinity. So we're going to start with the definition of both derivatives. And then divide them together. And we assume both functions are differentiable at c, and g' of c is not 0. Now if we look at a special case, where f of c and g of c are both large numbers that approach infinity, then what we get is the limit of infinity on infinity. Now rewriting this limit as follows, and you can see that we did not alter it. And now you can observe that we have a limit of 0 on 0. And we've also shown that L'Hopital's rule is valid for indeterminate limits of the form 0 on 0. So therefore we can take the derivatives of the upper and lower functions. So we use the quotient rule in the numerator and denominator. And now doing a bit of algebra, and now using the product rule for limits and cancelling out the negatives, we can evaluate the first limit. And for the second limit, we can also apply the product rule and recognize that this limit is f dash of c on g dash of c. So that will be f dash of c squared on g dash of c squared, which effectively equals f dash of c on g dash of c. And we've thereby shown that L'Hopital's rule works for limits of the indeterminate form infinity on infinity. We've evaluated this pretty standard limit previously using the squeeze theorem, and now let's evaluate it using L'Hopital's rule. So we can see that this is an indeterminate limit of the form 0 on 0, so we can take the derivative of the functions in the numerator and denominator. And therefore, we obtain cosine 0, which is the same result we got using the squeeze theorem. We've also evaluated this limit by multiplying the numerator and denominator by the reciprocal of the fastest growing term. But here we'll use L'Hopital's rule. So we can see that x goes to infinity in the numerator and denominator. So this is a limit of the indeterminate form infinity on infinity. So we can apply L'Hopital's rule. So differentiating the numerator and differentiating the lower function, so we still have an indeterminate limit of infinity on infinity. So we apply L'Hopital's rule again. And it's still indeterminate. So we differentiate again. And this gives 18 on 5, which is the same as the quotient of the coefficients of the fastest growing terms in the numerator and denominator.